feel like this is one of those watched pot situations. Okay, there we go. So my name is Chris Wilkinson, and I'm the Director of Planning and Architecture for Internet2 Network Services. That means that I wear a whole lot of hats. I help manage our architecture and engineering efforts, as well as I'm leading our optical RFP process as well. So that stack of hats gets a little heavy sometimes, but it's all good. I really enjoy it. I came from a research background. I worked for the majority of my career for astrophysics or astrophysicists. So I kind of have been at all levels of the sort of ecosystem. I worked within regional networks as well. So, some framing about kind of Internet2, just a couple of slides to start with. Internet2 is definitely a part of the ecosystem, the R&E network ecosystem. Our speaker on Monday showed a larger version of this slide of the marine ecosystem. And the image on the left is sort of one of my favorite images that depicts just a fraction of the R&E network ecosystem. So the main things that are visible there are Internet2, and ESNet is on that same general topology in red, the red dashed lines. All of the sort of little fireworky lines are all the regional networks. And then it's not visible in this view, but there's a line below that shows institutions, some of the institutional network backgrounds as well. So, Internet2 is just a part of that ecosystem. And as we get down into sort of what makes a next generation network, providing services throughout that entire ecosystem with all of these partners is sort of a key ongoing work in progress. So fortunately, there's a lot of great folks at all levels of that system. So, being an architect slash engineer slash operations person, I do tend to run towards hardware. And so, here is a sort of view of our physical topology. We have almost 16,000 miles of dark fiber. It's lit by a Sienna 6500 fixed grid optical system. We have 45 Juniper routers, and we move a whole lot of data every year on behalf of our community throughout those points. By far, the busiest path on the network basically runs from Los Angeles through Chicago out towards New York. And the rest of the network, still has quite a bit of traffic, but the east-west is definitely one of our largest segments. So what types of services do we provide? I think one of the interesting things, much like a lot of our regional partners and even some of the big state institutional networks, we're able to offer the full stack of services. So we have an optical system, we run layers 2 and 3. It includes everything from VLAN services up through, we don't provide full commodity, of course, but we do provide direct access to certain private peers through our TRCPS, now rebranded as Internet2 Peer Exchange, I2PX, recently rebranded. And we've been expanding into the cloud as well over the last 2 years. Throughout most of those services, except for layer 1, we have portal and API-driven capabilities for managing services at layers 2 and 3. We most recently deployed Cloud Portal, which I'll touch on a little bit later. And so one of the neat things about that is that we have full control over the stack. And when traffic enters at a campus border onto a regional, onto Internet2, back to a regional, onto a campus border, we can achieve a full understanding of where that traffic's going and why. So it's one of the major value propositions that we have. So most of this topology was built as part of the BTOP program. So at this point, we're starting to run into a number of capacity and power situations throughout the footprint. The original Sienna 6500 is quite large. It's quite power intensive. The MX960 platform does not have high density. So the question is what do we do about that? As traffic increases, as we want to keep fees reasonable, we have to take some action. So NGI was spun up. I think, you can't have a networking project without an acronym. So here we have NGI, because there's not enough acronyms in our lives. And it stands for Next Generation Infrastructure. Infrastructure is a little bit, tends to be a word, I think, that draws people into hardware or into something physical. I think it actually transcends that. Our intention is really to look at the full breadth of what Internet2 does, and make sure that technology portfolio is aligned with the needs of the community and the researchers, all the way down. So that requires us to really have a hard look at all those services that I showed on the left, make sure that there's still a need in the community for optical and layer 2 and layer 3 on a nationwide footprint. And then also figure out if the software enablement of all of those features is sufficient. And while we've had some software stacks in our operation, I think the need to do more and enable more direct access to the platform is definitely out there. And so even after that, so you look at, you have to ask the sort of what are you doing and why are you doing it? And you have to ask how you're doing it and if you're using the software properly. And then you get down to actually touching bits of hardware. So technology is important, the actual physical hardware, but it kind of is at the end of the day. It's at the end, it's at the bottom of that process. So, having thought about all that, you start to think about, well, what do I need to do to get started? And one of the first things that we did was, figure out what we need to do. So starting way back in 2016, Internet2 went through a series of community requirements gathering process. We tried to find out what stories folks had about the network and about how it needed to function and what types of things were developing out there. So between a bunch of face-to-face meetings, there was a paper process where a paper came out that sort of described the vision for the R&E community. This was this long acronym here, which I won't even try to stumble through. And then there was a series of we met with all the individual regional leadership as well through basically webinars. What came out of that was sort of an expectations paper, which we can definitely get a link for. There's a fairly short link that's really hard to see on this blue background, but happy to get that to you. It's publicly posted, publicly available. And then we started doing some proofs of concept and some piloting activities as well. So one of the things that came out of that was this guiding principle. I've already used the word ecosystem a whole bunch, but that it has to be an approach from end to end. It has to involve all of the partners, that we have to enable experimentation. We can't build this monolithic thing that can't change. It has to evolve over time. And that research is a focus. It's not just about the sort of production aspects or enterprise access, that we also have to enable the research aspects as well. So this is sort of a fun word map that Rob Vitsky put together from the various papers. It's sort of amusing to dive in and see whose names pop up in here. There's lots of regional networks that pop up in here. And things like software. Oh, even my name is actually up there. So I don't know what that means, but I promise you I didn't put it there. At any rate, so coming out of all these papers, what are the types of things? I've already mentioned some of these. We need to support research. It has to be programmable. The cloud is key. There has to be embedded security functions inside the network. And when I say network, I'm using that not just to mean the hardware, but the software stack and the higher level applications, better regional national integration, infrastructure sharing, which has a lot of, when you run a multi-stack network and you've got layers 1, 2, and 3, you can theoretically share all kinds of different parts of the network to help people save money. And that's not a one-way street. That's Internet2 sharing with the community, and then the community has resources that Internet2 can use. So it's a real honest look that we do not have to run everything or have all of our stuff on everything if the operational concerns. can be resolved. Obviously, there's enterprise support, global reachability. Telemetry is a really interesting thing because increasing the visibility of what's going on in the network and pushing that data out to the people who find that information most critical. And that's things like operational aspects, the usual boring stuff like alarms and counters, but also deeper things like how is the optical system I'm traversing performing? How is the packet network performing? Those types of things to enable people to figure out what's going on at any given time as well. Resiliency, of course, is important. And then economics, we have to keep the lights on. We have to be able to afford to run the gear, get down in that. So I'll just kind of shoot through these because I think they're all sort of familiar stories, but these were things that came out of the process of talking to community members that sort of shape our thinking on this. There's the data-centric researcher, large file sets between collaborators, fast transfers from lab to lab or lab to DTN. Things need to be simple. And the campus IT security needs to be enabled to facilitate that reacher to do their data, to secure the data and keep things flowing. Another similar use case, an end user at an institution, wants to make sure they understand and where their data is flowing, how they can send data. It needs to be portal and API driven, and they need to be able to make changes to the network sort of on the fly. Cloud migration, a common campus effort, is migrating things from the mainframe. When I came into R&E at the beginning of my career, everything was on a mainframe, sometimes not even in a data center. Maybe in a compute center, and as economies push things into the cloud, or the desire to have those applications be faster or more expansive, go into the cloud. That's obviously key as well for both research and administration. And then in general, networks need to evolve more rapidly. Capacity needs to be easily deployable, and sharing infrastructure is key to achieve those economic aspects. And then lastly, we get to the scale of economy. Bandwidth is obviously increasing more or less exponentially. This is actual data from Internet2’s network about how many petabytes we carry in a given year. That curve continues to go up. It's interesting, it ebbs and flows as things change. Maybe certain things drop off and certain things pick up, but we've yet to see this curve change dramatically or start to show signs of leveling off. So, that continues to be an interesting driver. Similarly, we've seen the cost of hardware components go down. And so this is a really interesting view of what has happened just in the optical space. So in 2011, we were deploying 100 gig circuits using these circuit packs that drew about 400 watts. That means in today's dollars, those cost about $1,400 a year to operate every single one of them. And there are hundreds of them in the network. Moving down towards where we are today in 2018, you've got pluggable coherent optics that can provide 200 gigs on a given channel. And, so the per 100 gig channel, you have to normalize this somehow because the original ones were 100, turn out to be $35 a year. So basically in 7 years, you've gone from needing $1,400 worth of power per year to drive a 100 gig circuit down to $35 per year to drive a 100 gig circuit. And that's on long haul, that's coherent. So these types of being able to kind of reset that economics, and this is just one part of that, is really an important driver. So, and I had to throw in, there's the unicorn optic as well, which everybody tells us is coming. It's just coming next year or next year or next year. it is a unicorn, but if it ever becomes real, it could be even cheaper. It could be a third of the cost of the current pluggable optics. So, you're talking 100th of the cost over the scale of effectively 10 years. It's pretty amazing. So what do these stories kind of tell us? I think we've seen all these before, but just to reiterate, data intensive researcher must be software driven. Cloud's important, has to be ecosystem wide, and we've got to reset our economics. And then of course, there's sort of the demand that the network, we're not going to deploy hardware. It's not going to sit around for 10 years and then we might forklift it. We need to be evolving all the infrastructure continually. New services come up, new demands come up. I think we saw the cloud coming 5 years ago, maybe longer, but it really came to fruition quickly on the time scale of a hardware deployment. So, there's dramatic shifts in needs as time goes on, and we've got to be better at getting there. So, the NGI project, how do we organize in a way that makes sense and that we can actually achieve our goals? So, the project that we've set up is really set up into three discrete areas. And they're shown in these overlapping circles. I like to say that this overlap was only done at this level for convenience. So those circles actually push a lot closer together. Software and hardware and services are all integral into. They're all sort of codependent, and they all have to fit together really closely. You can't have your hardware team building things that then the software team can't support or doesn't meet the needs of the software platform. So our efforts are basically in the green, which is sort of service definition, the yellow, which is sort of the hardware portions, and the red, which is the software portion. So that's kind of that's how we sort of self-organized. And then overarching through that is the community collaboration, which is key. We've got community at every single level of our effort. And then, of course, management and governance and experimentation. So we touched a little bit on the arc about where this process has taken us so far. Through 2016 and 2017, we were doing some pilots and gathering information. In 2018, the rubbers really started to hit the road. We've all of our committees are activated. We're running further pilots. We've gotten through our organization and development cycles as far as getting the project set up, and we have Cloud Connect in full production with the portal in place, and we've run some DTN pilots and a few other things. So as we go through all of these processes and every single one of these colors is activated, we're making parallel progress throughout. So it's interesting to sort of look at community expectations. There's a few specific technologies in here. So I have my mystical book here because somebody actually had a paper copy that they provided us from the 1999 effort, because way back then we did put things on paper, and it wasn't just in box where you can't find it. And so we actually went through the paper copy of the 1999 things, and we found definitely the top four were really prominently mentioned. We want QoS, we want IPv6, which IPv6 is done, right? So it's totally done. We want IP. Oh yeah, you're right. It's been done. Yeah. So we want IPv6 implemented. Let's not get into that. And jumbo frames and multicast were all pretty prominent. And of course, the things like we want resiliency and headroom and high performance. So, it's interesting to look at the specificity of what's happened in 2019. Now we have specific things like we want private L2, L3 networks. We still want resiliency and headroom, but now we also want security. Oh, and here's telemetry. We want to know what's going on with the network. And then the DTN applications have popped up. And so things have shifted towards being a little more specific and a little more towards some end goals. And of course, all those things need to happen across the entire ecosystem. So what are sort of some of the inspirations as we've gone through what new infrastructure might look like? So I'm going to just kind of march through some of the layers. So this is our optical service. Right now our optical service provides 10 through 100 gig waves. It does have a dark channel, which is kind of a foreign wave and it's kind of not. And we can do some fiber sharing, but it's a little difficult, and it's got fixed grid, so you're within a certain spectrum. And we're using a sort of distance and hardware-based model. So what tomorrow's network might look like is 400 gigs and above, right? 400, 600, 800. We absolutely need support for third-party transponders and fiber sharing. Flex spectrum is important. If you want to throw those distances, you've got to do it. You need the telemetry, and then we're going to probably need to shift our fee model, because a channel is not a channel anymore. It's a lump of spectrum instead. So, finding a system that enables us to do all these things is kind of key. Oh yeah, and then the date slip again. Like, yeah, this thing's going to be available next year, but maybe not. It's maybe 2020. So, by the way, optical is kind of our most mature of these explorations. So, we're already well into some of that. So what might it look like at layer 2 and 3? We've got 100 gig and 10 gig access now. We have an incredibly uniform network of large routers with big buffers and deep capabilities at every single site, which is awesome from an engineering standpoint. It's not so awesome from the power bill standpoint. And so all of our pricing is sort of a uniform connection-based pricing, and we've got some Cloud Connect as well. So tomorrow, what does that shift to? Same types of things. We go to 400 gig, maybe beyond as 800 gig comes out. There's different fee models that can be applied if your hardware becomes more flexible. Maybe you shift your entire topology. Right now we have all services everywhere, and we probably still will have that. But whether the local point of presence is directly providing some of those services, or whether you're doing more of a backhaul scenario, that could change. Maybe with segment routing, or you have a optical system that's more capable, you can make different choices about how services are delivered. And absolutely, we're back to this API demand and our portal enablement process, including our cloud connectivity. So, and delivering that telemetry. Obviously, peer and cloud connectivity has become more and more important, and we've evolved how we've looked at providing those services. Here again, we've talked about our OESS portal, enabling sort of both the campus users and the regional users to provision into the cloud. Another thing that we've seen recently is the rise of greatly increased regional peering, which is a great collaborative opportunity, both for people within the region and outside of the region, to not only use the Internet2 peering offerings, but also the offerings inside the regionals themselves. So enabling that kind of cross organizational use of resources is a real benefit for everyone. So that's a vision. A lot of this stuff that I'm talking about right now is visioning that we would like to enable. Additionally, we're trying to figure out other mechanisms that enable people to access things through our peering. We have our R&E peering. We have I2PX, which is more generic. Plus, we'd like to enable this sort of pop-up router concepts to come as well. So that's the rapid deployment. Just a few quick conceptual things. A lot of them are based around cloud or delivering PNIs into the regionals, or through a regional onto a campus, and virtual networks. We're really trying to think about how that portfolio and the building blocks that we're using play out. And then we get to software, probably one of the most critical pieces. I mean, all this other stuff has to go right, and we have to have a good conceptual thing. But the software has to really be tight. I mean, it has to automate the majority of the stack. It has to really be self-service, and you have to have APIs into it. And those measurement and analytics tools have to support all that. Getting a bunch of raw, unprocessed data out of the network probably isn't useful, but getting a summary or a data package is sort of key to enabling people to actually understand what's going on with their application or with their network connectivity as it traverses not only the Internet2 network, but also the regional networks between. And one way we're going to approach this is we're going to start to build some test beds later this year to kind of really start to explore how that might work. Software is not just orchestration, or it's also automation for internal use, making the work of our engineering staff more streamlined, so there's less human error, things can happen more easily, people are getting woken up less in the middle of the night. That's a big thing for us. So I've touched a little bit on this, but I wanted to, a lot of this sounds a little esoteric. It's actually, there's actually a lot of activity that's ongoing right now. I've mentioned a little bit of it. Cloud Connect has gone live. It is in use. In fact, its utilization has really exploded in the last 6 months. We're adding capacity into that system a fair amount and making sure that we've gotten a lot of new requests recently about new cities to connect in regionally. Our traditional TRCPS cap was 20 gigs and more regional. That's been raised, and we're doing an extensive number of upgrades in our peering locations. And we've recently released our optical RFP as well. So that's great. That optical RFP is intended to refresh all of our photonics, implement all the features and drive out costs. It has been pretty interesting so far. We've gotten 13 proposals from 8 manufacturers. They were sort of separated into an open line system aspect and a transponder aspect. We wanted to do that so that we could evaluate them separately. The responses were really quite excellent. I think almost all of them were of high quality. Everybody took a lot of time to have a look at what we were asking, and we're about to go into a second or sort of next round process there. So in a couple of weeks, we're going into a best and final with a select set of vendors. The plan currently is for us to upgrade our line system first, then move on to the transponders. We can use our existing transponder platform in whatever line system we move to. So we can do it in sort of a step-by-step basis. Layer one transport, transponders, layer 2 and 3. We don't have to do it all at once. And we really can't. We can't forklift the live network. So hoping to have our first segments up in 2019 yet this year, hopefully in advance of SC. The layer 2, layer 3 efforts are just starting to get launched. We released an RFI to, again, a select number of vendors, asking them to come in and tell us what their vision is for what a modern network looks like. So, and that network, as previously mentioned, it has to support enterprise traffic, and it has to support these large flow research applications as well. So as we've gone through the various architectures, you talk to somebody from Google, they talk about low buffer or zero buffer networks. You talk to folks who have traditionally been in RE, everything needs a deep buffer. Answering those types of questions are sort of key about figuring out what we're going to build, because we don't just want to replace the current infrastructure with new infrastructure. We actually want to ask the big questions about, what do we really need? And how does the software and the automation tie together? So really excited about that. We're going to be doing some vendor workshops, which some of our community panels will be invited to. And we're really hoping to get some sort of key designs out of that. Heading towards third and fourth quarter, we'll be evaluating, we'll issue an RFP, and we'll actually be looking for hard responses. So infrastructure upgrades are already happening as part of NGI. We've needed to make some moves. The network doesn't stand still. That graph still keeps going up. So we've had to actually retool some of our sites with new hardware. We've got our MX960 platform, which served us faithfully for many years. Juniper has an MX10000 series now. We've gone ahead and installed a few of them. It's been a great process because it gets us more comfortable with the current hardware families. We really wanted to wait for this, but we really just couldn't. So, so we've moved into that, and the operational costs alone are amazingly different cost scales. More locally in California, Internet2 has points of presence in Los Angeles and Sunnyvale in the Bay Area, and we've been doing some interconnection upgrades there. We recently built out a new, we acquired a new fiber IRU and put a new AL1S node at Equinix SV1, enabling us to pick up Cloud Connect services at that location. That it's currently in commissioning. It's a redundant fiber loop with pretty much all Internet2 services available at it. We built that out kind of assuming that there was going to be a fair amount of infrastructure sharing through there as well, which is slowly developing, but that capability has been a work in progress and is coming along. From a software standpoint, we've been working pretty hard on our cloud portal. I already mentioned that. And that portal basically allows users to go in and provision endpoints within AWS, GCP, and Azure directly to the edge connectivity for their regional. Then you can build VLANs through your regional on your campus. But that portal is available today and is fully enabled. If anybody's interested in it, then be happy to talk with you. That is sort of a base core service of Internet2 now, so it is really available for all use. And then last but not least, we did a technology demonstration with Arista at Technology Exchange last year, looking at segment routing and their current offerings. One of the things that really it needs to be a continuing effort, these are all sort of efforts which feed back into themselves, is continuing to look at our community expectations and what things the community is looking for. And that community includes not just the regionals, but sort of the cloud architects on campuses, the researchers, the security officers, all those folks. And so one of the most important efforts that's going on right now is trying to spin up a new community expectations task force to draw all those people together and continue to guide this project. The hardware efforts will continue sort of for the next 2 to 3 years. But because of the nature of, or I should say the flexibility of a lot of that equipment, we believe we can continue to evolve the service layer, not independently, but in step. So one of my big messages for this talk is that there's still a lot of input and a lot of valuable contributions that can be made to kind of where this project ends up. The RFPs for the hardware are one thing, but developing the services, the fee models, and what actually we end up with in 2022 still has room to go. So, and with that, I will take questions. It is. It's right there.
There's no light on this one, but it works.
Thanks, Chris. Von Welch, Indiana University. Question that's been bugging me that came out with your graph of all the petabytes being transferred is data integrity. Mm-hmm. So Vern Paxson back in '99 showed TCP checksums are getting stretched, and he even had evidence at that point. So I'm sort of curious, as you go through this NGI process, are you doing anything looking at, sort of at layer 3, layer 4, without some sort of application level integrity protection? What guarantees are you giving that data scientist, and what responsibilities do they need to take on if they want to, ensure some degree of data integrity using Internet2?
So I think that there's, I'm on a little bit of being a network engineer mostly, I'm on a little bit of the edge of my knowledge here. One of the key functions that we've talked about is there are opportunities with segment routing like SRTE to take data flows and move them through maybe inspection's the wrong word, but to enable some form of inspection at a campus's request of certain types of flows to gather more information. But I don't know that I'm quite hitting an integrity. I mean, when I view sort of data integrity as a question, I would solve that problem both at the human level by coordinating between the folks on campus and our operations center, as well as giving enough telemetry back to analyze the sort of TCP state of that flow as it goes through the network. And that would have to be a collaborative effort. So I don't know if that answers the question or not.
I'll just make the follow-up comment then. I think what would be useful is if Internet2 could, make even a simple statement. Look, if you do a petabyte transfer with just TCP and no application level integrity checking, you are going to get, how many nines of integrity guarantee, or is it 100? Or if the scientist now owns some responsibility, then make that clear.
Okay.
Because I think there's sort of a default assumption in everyone's head that the IT infrastructure is sort of perfect with regards to integrity. And I'm worried, I don't know, you guys maybe have the telemetry today to sort this out, but at this number of petabytes, I'm very concerned that's just not true anymore. But it's the assumption in a lot of people's heads.
That is, yeah. And I mean, certainly from a headroom perspective, we try to maintain our headroom. But I agree, it would be good for us to figure out what the right statement is there. Yeah, thanks for the feedback.
I got a question for you, actually. And feel free to skip on this one because I'm not sure if this is going to be in your realm. I've been just thinking about some things as you were going through the presentation. The DDoS mitigation for Internet2, the CENIC Oracle solution. Can you speak a little bit about how that worked for you guys? Since, essentially UCs are about to sign up for it.
Okay. That is definitely not my area.
Okay.
But I would be happy to connect you with somebody.
Okay, that's fine. Okay.
Yeah.
Then my next one is actually probably more in your realm. So your cloud comment, since you guys are doing work in the cloud, is it your private cloud, AWS, Microsoft, and why cloud for Internet2?
Why cloud? As opposed to well, first and foremost, we've received some very direct requests to provide that type of connectivity for campuses. I mean, some campuses are in regions where they can directly connect to.
So it's for connectivity purposes. It's not something you're actually hosting something in the cloud.
That's correct. Yeah,
gotcha.
That's correct. Yep.
And one more from me. Your thoughts on Arista? So you guys are looking at them. Any general idea as far as if you feel that they're ready, not ready for Internet2?
If you had asked me this question maybe 5 years ago when they were first sort of surfacing, I would have said, I don't know. But I think what we've seen so far is that they have a strong product portfolio. They seem to have deep technical staff, and I'm not in any way advocating for Arista, they definitely received our packet RFI. And we definitely hope, just like Juniper, just like Cisco, and the other big players in the area, Nokia, we hope that we'll get responses, strong responses from all of them.
Okay. Questions? Okay.
I'm Rob Osborne from the Public Utilities Commission. I have a fiber-related question. Do you ever find that there's segments of your network that are becoming limited by the age of the fiber? And how do you detect that and replace it?
So we do have a monitoring program. It's somewhat passive, but we do watch sort of the quality of our fiber and look for overall degradation. So we have a 20-year IRU with 2 10-year extensions, I think, or maybe it's 2 5-year extensions. We're about halfway through that. And sort of categorically across the system, we've seen only very minor deviations in sort of the quality of the fiber or the throughput characteristics. Now, we don't have any sort of deep characterization ongoing of that fiber. We just monitor light levels and, aside from the usual squirrels or techs in the hut that unplug the wrong thing, which happens all the time, more than it should. We haven't seen any sort of large scale degradation of the fiber plant. In fact, one of the things that was asked in our optical RFP similarly is, can some of our optical gear continue to operate as well? So same fiber, same optical gear for the next 7 to 10 years. I don't think we have any concern at this point. Most of our fiber is SMF28 or E-leaf. So, we don't have some of the other LS, we don't have a lot of LS fiber or, other fiber types in our network either. So that's the long answer.
I didn't think that anybody else had possessed fiber-tuned squirrels except UCSC.
They love it.
I don't know why. Here we go. Let me see if I can jump over a chair or two.
Chris, Steve Corbido, Lincoln, Oregon. How do you see the topology of the network changing over time, with particularly based on the cost analysis of the RFP responses? Do you see more pops, more nodes, less nodes? What are the drivers right now economically?
I hope our baseline is that the economy of scale of these new systems will enable us to keep the existing footprint if we choose to. If the community demand sort of remains the same, I think our belief is that we will be able to afford to keep the same footprint. So whether we should keep the same footprint, I think, is an ongoing question. Especially with there's some very strong regionals with very strong fiber infrastructure. There's developments in the open ROADM program and those kinds of things. So in 5 years, we may not have some of our segments. They may be shared. But we haven't seen a drop in folks asking us to you guys don't need to be in Las Vegas anymore. So if we can afford to keep the points of presence for the community where they are, then as the needs change, whether a node's an AMP site or an add drop site, from 1 year to another is almost irrelevant. But if the physical topology is there for the community to leverage as the community needs change, I think there's a benefit. So, we certainly have looked at some things like the northern tier to see if there's opportunity there for the community. But the topology we have, the big map certainly has a certain overall level of utility for the community that I think benefits everybody in the ecosystem.
Thank you. Any other questions? Okay. Let me figure out the logistics of how to get there. I can throw the microphone, but it's on record, so.
Hi, this is Alan Jahami with Cisco. Just a business question. At the state and city level, we're seeing a lot of public-private partnerships being formed, primarily to fund this.
Mm-hmm.
Do you see this happening also at the national level?
So give me an example of how a public-private partnership in your specific context would.
With Arizona,
mm-hmm.
there's the AZIDP,
mm-hmm.
and it's a nonprofit that's putting together business alliances with the universities, with
mm-hmm.
fiber providers to build out a statewide fiber underlay that supports generally the state as the primary tenant, but
mm-hmm.
also reaching out into potentially K through 12 universities, as well as private industry that helps to fund it.
Right. Yeah, I think we've seen similar things in a few other states with that specific example. Yeah, we haven't. We have very good relationships with our providers, but we haven't yet seen that kind of come together at the national level. Yep.
Any other questions? Going once, going twice. Okay, I think we're adjourned. Thank you so much, Chris.
Yeah, thank you.